Welcome to the Faith Lab. My name is Pomoroka Blessings, and today we're trying to focus much more on back titration. Determine the percentage of ammonia in the household ammonia. So now, in this important equation, and in this important experiment, it's actually one of my favorite because it gets to explain exactly what we do during titration, and it gets to give us a major difference between the normal titration as well as back titration. So in back titration, much of what we're going to focus on here is on the reactions that have been provided. Okay, so when you get back to your lab manual, this is just the basic principle that lies in back titration. I want you to discover something here. Even when you walk into those lab sessions, you have a clear organic analysis and spectroscopy analysis of what you're supposed to do while you work on such kind of procedures. So now, you're going to be provided with the ammonia here. All right? You're going to be provided with ammonia, and the other thing that you're going to be given here is the acid. And then, so you're going to have two equations. In the first part of the reaction, you're going to have ammonia, which is going to react with the acid, which is HCl, to give us the product ammonium chloride. In the second part of the reaction, you're going to have the sodium hydroxide, which is the base, going to react with the acid, giving us ammonium chloride plus the water, because you know what to say in an equation where you get the salt plus the water, you just get that is a neutralization reaction. So now, in the first part of the reaction, we have here is we're going to mix the 5 cubic centimeters of the ammonia, which is the analyte here. We're going to mix it with 25 mils of the hydrochloric acid, which is going to give us that product. So now I want you to understand something in back titration here. This is the basic principle that lies in back titration. You are going to be given the concentration of the HCl. You are also going to be given the volume of the HCl. I think when you get back to your lab manual, you discover to say, we were given the concentration of the HCl as 0.1. All right? So the concentration of the HCl here is 0.1 molar. You're also going to be given the volume, which has already been given when you check your lab manual. You're mixing 25 mils of this. Okay? So the volume here has been given as 25 mils. Mixing what volume of the ammonia has been given here. The concentration has not been given, but what has been given here is the volume of 5 cubic centimeters. So now, the basic principle here is that the ammonia, which is going to be limiting reagent, okay? It is going to be the limiting reagent in this chemical reaction. It's going to react with the excess HCl, going to give us the product. When this reaction happens, what is going to happen exactly is that the ammonia is going to go out. It will be completely diminished during the course of the entire reaction because it is in the limiting state. So meaning that since we still have the HCl, it is going to take place in the second part of the reaction where you have the titration reaction. So now the HCl here is still present, going to react with a certain concentration of the sodium hydroxide, going to give us a salt plus the water here. So now, the sodium hydroxide, whose concentration has been given, when you get back to your lab manual, you discover to say the concentration of the sodium hydroxide is 0.1. And we're also going to know the volume here, because the sodium hydroxide now becomes the major titrant. All right? It becomes the major titrant. What you're going to have in your burette is the sodium hydroxide, which is going to be the titrant, as indicated there. What you're going to have in your conical flask is the HCl, which reacted in the first part of the reaction with the ammonia, because the ammonia was completely vanished because it was in the limiting state. You're going to have HCl, and then you're going to add 2 to 3 drops of the indicator, which is phenolphthalein. And then you are going to titrate. What we're simply doing there here is, we're trying to find out what are the moles of the hydrochloric acid, because we don't know the moles here. And then because this was limiting, we expect this to be in excess. So in the second part of the reaction where we have titration, since we have the concentration of the sodium hydroxide, which is 0.1, with a certain volume, which we're going to find out because we're supposed to titrate this. We're going to find out what we're calling the mean titer volume of the sodium hydroxide, which is going to be our overall volume here. So now by doing this, you know to say the mole ratio here is 1:1. You can find out the moles of the HCl. When you find out the moles of the HCl, what you're going to have here are the moles that will appear in excess. So now to find out the moles of the ammonia that will react in the first part of the equation, what we're going to do here is we're going to subtract the moles that we had here initially because the volume was given. We know you can find out, to say concentration is equal to number of moles over volume. You can find out the moles because we have a volume of 25 cubic centimeters here, and then we have a concentration of 0.1. You're going to find out what we're going to have here got the initial moles. And then here, you can also find out the moles of the HCl because the concentration of the sodium hydroxide has been given. And when you find out here, these are the moles in excess. And finding the difference between the initial moles that were here from the moles of the HCl that were in excess is going to tell us the moles of the HCl that were reacting the first part of the reaction, which are going to help us to find out the moles of ammonia, which is NH3. So that is back titration. You're working from the second reaction to get back and see what was the reaction in the first part of the reaction. So simply that is how you work it out. But remember, our overall objective in this reaction is to find out what? The percent of ammonia in household ammonia. So when you get back here, we have the density, which is 1.0 grams per cubic centimeters. And then what we're trying to find here is this is the density of the ammonia which has been given. Okay? And we know to say density is given by mass over volume. So we're going to find out the theoretical mass using this formula here. The theoretical mass is going to be density, which is 1 there, multiplied by a volume of what? This is 1 per cubic centimeters. 1 per cubic centimeters multiplied by the initial volume that we collected for the ammonia was 5 cubic centimeters. And when you work out this, you're just going to have a 1 gram. And then the actual mass that we got here of the ammonia, you are going to break them out throughout the entire course of the reaction because you now know the moles of the hydrochloric acid that were acting with the moles of the ammonia. And you're going to find out what are the exact moles because when you know the moles, you can still find out the mass because you know number of moles is given by mass over molar mass. We know the moles. You're trying to find out the mass, then the molar mass. So you're going to find out the exact mass moles of the ammonia that were reacting in the first part of the reaction. So now this is the basic introduction or the basic principle that lies in back titration. So now let's get back to the entire course of the practical and find out exactly what we're supposed to do. Thank you. All right, so in this session, we want to look at the technicalities of procedure. We want to start first of all with the first part, the second part of the experiment, because we are looking at an important reaction here, which we're calling back titration. And then when you get back to your lab manual, you discover to say much of the reagents has been given. So we've been given ammonia here. Therefore, we have been given ammonia there. And then the other reagents that have been given in this chemical reaction is the hydrochloric acid or the HCl. And then the other part that we also need here is we've been given the indicator. We've also been given the sodium hydroxide, which we're going to use as the titrant. Remember in the first part of the video, I made a clear distinction between the analyte, the titrant, as well as the other important parts that we need in this chemical reaction. So now, what's the first part of the procedure? The first part of the procedure is telling us to say, we are supposed to pipette 5.00 cubic centimeters of the ammonia solution into a 250 ml conical flask and pipette 25.00 milliliters of 0.1 HCl and add it to ammonia solution. So now, the ammonia is right here, all right? And then the HCl is right here. So we're pipetting the 5 cubic centimeters of the ammonia into the solution. So first of all, This is the ammonia that we have right there. So we are pipetting 5 cubic centimeter of the ammonia, and then we're going to get 25 cubic centimeters, 25 mUs of the hydrochloric acid, whose concentration has been given as 0.1. So therefore, if you check your burette, if you check your pipette, we have 1 there, 2 there, 3 there, 4 there, 5. So we're pipetting 5 cubic centimeters of the ammonia. So we're getting 5.
Yes. How are you? Fine. So how are you? Fine. How is it going?
Okay, so that is 5. So if you check from here, we already are having the 5 cubic centimeters of the ammonia.
So we just have one group today.
Okay, we have put that in our conical flask. That is the first part of the experiment that we're doing. We're mixing 5 cubic centimeters of the ammonia, which has already been mixed right there. And then the second part of the experiment, we're getting 25 cubic centimeters of the 25 cubic centimeters of the hydrochloric acid. Okay?
Yeah, it's better to have half day.
Of the hydrochloric acid. So remember our HCO is in here. This is our HCO there. We're getting 25. We are already at 24 there. We need to get 25. So the pipette runs up to 24 mUs. So remember what we need here is 25. So my 24 is in there. We need 25. So I'll just add on 1 mu there. All right, mixed. So remember, 5 cubic centimeters of the ammonia has been mixed with 25 cubic centimeters, 25 mUs of the hydrochloric acid. So now the second part of the procedure is telling us to say we're supposed to add 2 to 3 drops of the phenolphthalein indicator. And the phenolphthalein indicator is here. We have it. And we're adding 2 to 3 drops. 1, 2, 3. We've added the indicator. And then we're supposed to mix. Okay? So mix the mixture to react for about 5 minutes by shaking the flask slightly. So allow the mixer to react for about 5 minutes by shaking the flask slightly. All right, we're done. So the second part of the reaction that we're trying to focus on here is where we're going to add the sodium hydroxide, which is the major titrant in here. So in the beer, what we have here is sodium hydroxide. Then the sodium hydroxide is going to titrate with the what? With the HCl that is in the conical flask. So remember, in the first part of the video, I mentioned to say what we have there is the ammonia plus the HCl. The ammonia is the limiting reagent, and the HCl is the one that is in excess. So remember to say, in the first part of reaction, the ammonia reacted with the HCl to give us ammonium chloride. So to mean that since the ammonia was the limiting reagent, we expect that we're not going to have much of the ammonia in the chemical reaction, but what we're going to have is the HCl, which is going to react in the second part of the reaction, which is this one right there. So now we're now going to titrate the HCl with the sodium hydroxide. So now I'm going to do the first part of titrating. Okay, so I'm starting from 0 here. What we have in the burette here is the titrant, which is the sodium hydroxide. And what we have here in the conical flask is more like the HCl. Because in the first part of the reaction, while we mixed with ammonia, the ammonia was the limiting reagent, and then the HCl was in excess. And even when it gave us the product ammonium chloride, what we still have in the conical flask here is the HCl.
Lab question. Then nalakuma one side lab banan kaneva changes we lab for the thing.
All right, so you can see that we have titrated, which was the major titrant, the sodium hydroxide, mixing what we have in here. And then we have a change of color there. So I mean, this is the first titrant. And when you get back to your table, there is showing titration of HCl with 0.1 sodium hydroxide. So we have the first one here, you record. So we are starting from 0 there. And then we have the first one as 16.16. The first trial that we have here is 16.8. Okay, that's the first trial that we have there. So our initial volume that we started with is 0. And then we have our final one as 16.0. So we're equally going to do the first one for the first part, the second part, as well as the third part. All right, let's move on to the second part. So yeah, we've already done the first part of the experiment where we've done trial 1. So when you get back to your lab bank, you're going to notice to say I've got the first part, which is a trial, and then the accurate titration. We need to titrate the first part, the second part, as well as the third part. So I did titrate for the first part. Let's now titrate for the second part. We're still going to repeat the same procedure. Remember, 5 cubic centimeters of the ammonia, and then 25 cubic centimeters of the HCl. So now I'm using this pipette to titrate for the HCl, and I'm using this pipette here to titrate for the ammonia. Let's repeat the exact procedure. So what are we collecting? How many volume? What's the volume of the ammonia that we're collecting? 5 mUs. We're trying to make sure we're accurate as possible. So we're collecting 5 mUs of this. Okay. Collecting 5. Okay. Ammonia. And then 25 mUs of the HCl. So remember, it goes up to 25. All right. So we've mixed the first the reaction, the ammonia plus the HCl. So the second part of the procedure, we're adding 2 to 3 drops of the indicator, phenolphthalein. 2 to 3 drops. 1, 2, 3. Then we're mixing slightly. Allow the mixture to react for about 5 minutes by shaking the flask slightly. All right, so we've allowed this one to mix for 5 minutes by allowing the mixture to react. And then the second part was supposed to titrate to sodium hydroxide. Remember, what we have in the burette here is a titrant, which is sodium hydroxide. And then we have our mixture here. We added 2 to 3 drops of the phenolphthalein indicator. And then now remember, in the first trial, we got a certain volume of the sodium hydroxide from the burette. So now we went on to 16.8. Okay, that was the first trial. We moved on from 0 there. We traveled to 16.8. If you want, you can refuel up to 0 so that you can get the first part. But again, if you want, you can make the 16.8 as your the initial concentration, the initial volume of the sodium hydroxide, and then what you're going to have the final, you're going to record that. So we are starting from 16.8. If you want, you can refuel up to 0, then you start over again, making our initial concentration of the our initial volumes of the sodium hydroxide as 0. But for now, what I'm going to do is I'm going to consider the 16.8 as my initial volume of the sodium hydroxide. So we can start titrating now. All right, there we are. So we can see that there's a color change there. So now, remember the initial volume of the sodium hydroxide was 16.8. Where are we going to? We're now at 35.4. So our initial volume you're going to record in the lab manual is it? In the lab manual you're going to record, the initial volume is going to be 16.8 from the first trial, and then your final becomes 35.4 mils. So now that is the second part of the titration. We're titrating 3 times. So we now again discard this, and then we titrate the second part as well as the third part. Then from there, we're going to find out the mean titer volume. So now we've done the titration. We've done the trial one, the first part, the second part, as well as the third part. So now we have like certain volumes. For the trial, the accurate titration of the first part, the second part, as well as the third part. So from there, we're having about how many values? We're having 3 values. And then we're going to find the average of those values. And when we find the average of those values, we're going to call that the mean titer volume. So now, from the titration that we conducted, the first part that we conducted, the second part as the third part, I have found my mean titer volume as 16.8. All right. So after finding your mean titer volume of 16.8, this becomes the volume of the sodium hydroxide. Okay. It becomes the volume of the sodium hydroxide. Now, remember the first part of the reaction we had what? The ammonia was reacting with the HCl to give us ammonium chloride. So now we said in the first part of the reaction, what we're given there is the concentration of the hydrochloric acid, and we're also given the concentration of the concentration of the acid was given, the volume of the acid was given, but the concentration of the analyte was not given, which was the ammonia. But the volume was collected. All right? And the second part of the reaction where we're titrating, we had the volume, we have the mean titer volume of the sodium hydroxide. And we also have the concentration of the sodium hydroxide. So from there, it's quite easy for you to find out what moles of the ammonia were reacting in the first part of the reaction, because the acid in the first part of the reaction was in excess. So because it was in excess, we're going to use the second part of the reaction to find out what moles of the acid were reacting in the first part of the reaction. And then we're going to use the mole ratio, because we know that in the first part of the reaction, the mole ratio is 1:1, to find out the exact moles of the ammonia that we're reacting. Then from there, we can now find the mass, and when you find the mass, that mass we're going to find is called the actual mass of the ammonia. Then the theoretical mass is going to be found by determining, the first of all, the density of ammonia, because we know that the density of ammonia is equal to the density of water, which is just 1 gram per cubic centimeter. And then we have the mass, which is going to be the actual mass there. We have the molar mass of the ammonia. So density is equal to mass over volume, and when you get the mass, we call that the theoretical mass. So to find out the percentage of the ammonia in the household ammonia, what you're going to do is the actual mass over the theoretical multiplied by 100. So that is how you work out the entire lab session, and that is how you do your data analysis. So just make sure that when you're working out this lab report and you're doing those calculations, you consider back titration, because you're working from the second part of the reaction and going back to the first part of the reaction, finding out the exact moles and the masses that we're reacting. So thank you so much. Watch out in the next session.